Here's a little experiment to help us understand why we observe enhanced charging in winter. So in winter, the air is more dry, and for example, today we have 30% relative humidity, and this is known to cause a higher risk of electric shock because we charge more. But the question really is, why is that the case? And you find a couple of theories about this. One of them says that we have more discharge due to the moisture in the air. So in other words, there's a thin film of some water onto our charged surface that then evaporates, and the evaporating water molecules somehow take the charges with them. The question is that effect strong enough or not? And another theory says that there's essentially, due to this thin water layer, there's a better conductivity, and then when you're basically charging you're trying to charge your body by rubbing two surfaces together, then there's an immediate discharge because of that conductivity of that water layer. And so we're going to try this out with an experiment with an electrometer that you see on the left side and you see on the lower part. So essentially somewhere here there's a little indicator, and that tells us the charge on this scale here. And we will first charge the electrometer by rubbing some fur with a plastic stick, and then put these charges here. You will observe a charge, and then we will observe how quickly, as in a sort of compressed time sequence, how quickly it discharges. And then we will do the same by putting on top here a damp cloth or damp piece of paper. So there will be lots of water here that should make it really easy for the charges to evaporate. And let's see what we will observe. So here you see the electrometer being charged, and you also see it's kind of difficult to do so. And then, as you see now, the charge remains really stable for a period of about 3 minutes. And now I put this damp cloth, you see the dampness here, and it was really easy to charge, actually much easier than before. And you see also within that time it's totally stable. So we couldn't see any really difference in discharge, but we could see an easier transfer of the charge. And so if we translate that to our original question, I think it pretty clearly shows that the main effect is really a discharge that happens by connecting yourself to the ground, essentially when you're trying to charge yourself. So it's less charging, and it's not the effect of some charges vanishing much better. If you let this experiment run for much longer time, you can actually see a difference in the discharge as well, but it's really, really slow and comparably small of an effect. So I don't think it really contributes to the practical effect that we observe. So I hope very much that this helped clarifying the situation.